Today we're going to talk about classifying numbers. Types of numbers that we use on a daily basis. Natural numbers are the counting numbers that we're used to when we first start counting. It's all the whole numbers starting at 1. For example, 1, 2, 3, and so on. They go on forever. Whole numbers are 0 and the natural numbers, numbers that don't contain any fractions. So then these would start at 0 and go 1, 2, 3, and go on forever. Integers are positive and negative whole numbers. These also do not include any fractions. So for instance, -3, -2, -1, 0, 1, 2, 3, and they go on forever. Notice I'm putting these 3 dots. That means it goes on forever this way, and it goes on forever that way. Rational numbers are any number that can be expressed as a ratio, rational, or a fraction of 2 integers, and the denominator cannot be 0. These do include repeating decimals. So for example, 3/5, 4/7, 0.3 repeating. That repeating bar tells us that it actually is the same thing as saying 0.3333, and the 3's just go on forever. You can actually have 0.145 repeating. The repeating bar goes above the 145, so that's 0.145145145, and the 145 goes on forever. If you have 0.83 repeating, the repeating bar is only over the 3, so that's the same as saying 0.8333, and only the 3 goes on forever. An irrational number is any number that cannot be expressed as a fraction of 2 integers. So means not, irrational, not rational. If written as a decimal number, the number would have an infinite number of digits to the right of the decimal and would have no repeating pattern. So for example, pi is an irrational number. We can approximate pi by 3.1415, and it goes on forever. But it goes on forever and it never repeats. Another number, if you keep going in math, is e. We can approximate e as 2.71, and that goes on forever and doesn't repeat. E is the natural number. Any square root that doesn't have a perfect square. So the square root of 2, if I say, what is the square root of 2? And you pause, that's an irrational number. Versus if I said the square root of 4 and you said 2. If you can come up with the square root right away, it's not an irrational number. But if you can't, then it's probably an irrational number. Some other irrational numbers that we can talk about are numbers that don't repeat and never end. So we could have a number like 3.455454555, and that goes on forever. This does have a pattern, the 4's and the 5's, but we keep adding a 5, so it doesn't have a repeating pattern. that's an irrational number. And it has those 3 dots that go on for forever. Real numbers are any number that is rational or irrational. And note, a number cannot be rational and irrational at the same time. For example, any of those numbers that we just talked about are real numbers. So 2 is a real number, pi is a real number, 4/5 is a real number. All of the numbers we just finished talking about are real numbers. A complex number is any number that can be written in the form of a plus bi, where a and b are real numbers and I is the imaginary unit. I is equal to the square root of -1. It doesn't sound like it's a very important thing because we call it imaginary, but it actually has a lot of applications in physics and engineering. So if that's something you're interested in, that's one of the things you'll be able to do. For example, complex numbers, a and b are any real numbers, and then we have that I. But remember, b could be 0, so 2 is actually a complex number. 4 plus 5i is a complex number. 7i is a complex number. Pi I is a complex number. Anything that has any number that we talked about as a real number plus anything with an I is a complex number. Number systems as a diagram. Sometimes it's easiest to see what the number systems look like if we have this diagram. So first of all, we have natural numbers. So that's 1, let me change colors. 1, 2, 3, and those go on forever. Those are our natural numbers. Then we add our whole numbers. So whole numbers is the natural numbers, because the natural number is inside the whole number, and our number 0. Then we add our integers. So integers include whole numbers. Whole numbers is inside integers. And natural numbers is inside whole numbers, which is also inside integers. Plus we have our negative numbers. So -1, -2, -56. All of our negative numbers are also in there. Then we have our rational numbers. So rational numbers include integers, include whole numbers, include natural numbers, and then we also add our fractions. So 4/5, 3/2, 2.7, because remember we can write the 7 as 7/10, so that is a rational number. And it included repeating decimals, so 0.3 repeating. Those are all rational numbers. Next we have irrational numbers. Notice the irrational numbers are different. There's no including there. There's a little space there than the rational numbers. So our irrational numbers are like pi. We talked about e a little bit. Square root of 2. Square root of, say, 7. And then those weird numbers that we can write without a repeater, without a and never end. So you could write, if you just started with random digits, you could have 3.452, and those are just random digits, and it goes on forever. So that's another one that repeats, or doesn't repeat and doesn't end. Those two sets together are all the real numbers. So we have all the real numbers is everything in that box. Last, we can add our complex numbers. Notice the complex numbers, the box is around all of the real numbers. So that includes our irrational numbers, it includes our rational numbers, which include the integers, the whole numbers, and the natural numbers. The only thing we're adding when we add our complex numbers are the I numbers. So I, 3 plus 4i, pi I. All of those I numbers are also added into the complex numbers. The i's, though, are not part of the real number system. So the i's are only complex. So let's talk about how to find out if show that things are rational numbers. We want to show that each number is rational by finding a ratio of two integers. Well, we know that 4 and 5 are integers, so this is actually a ratio of integers already, 4/5. -9 is a ratio of two integers. If we have -9, so we need their negative, the -9 is an integer, and we divide it by 1. 1 is an integer. -9 divided by 1 is equal to -9. We could also do 9 over -1. That's the same thing. 9 and -1 are integers also. 6/10 is 6/10, so that's 6 over 10. So that's how we can write that as a ratio of two integers. 0.6 repeating and also 0.3 repeating are two that you're going to probably have to memorize. 0.6 repeating is equal to 2/3. 0.3 repeating is equal to 1/3. These are two that you will have to know throughout the semester. -4/5 we can write as -4 over 5, or we can write it as 4 over -5. Those are both integers. -4 and 5 are integers. 4 and -5 are integers. Notice, for -4/5 and -9, we only wrote the negative once because there's only one negative. 0 is 0 over any number that you want. You can do 0 over 1, 0 over -3, 0 over 10. Those are all equal to 0. We want to identify the real and imaginary portions of the following complex numbers. So remember, we had the a plus bi. The a is the real portion and the bi is the imaginary portion. So for 4 minus 5i, the real portion is 4 and the imaginary portion is minus 5i. -6, the real portion is -6. The imaginary portion, because there's no I, it's 0i. The real portion for 3.2 plus pi I is 3.2, and the imaginary portion is pi I. 7/3 I, there's no real portion, so it's 0, and then the imaginary portion is 7/3 I. That's it for today. We'll talk to you tomorrow.